Hi everyone, my name is Eugene Lisyonek. I'm going to tell you about Spark 3.0 and Databricks. So what I wanted to cover in this session is not only an introduction to Databricks and Spark, but also some philosophical questions which have worried me for a long time. As I'm coming from a database background. So I've worked with databases for more than a decade. I've worked with different kinds of databases, Oracle, SQL Server, MySQL, Postgres, and whatnot. And the rug with the big data technologies and big data processing, I've always wondered how I would solve these problems with traditional databases, RDBMS systems. During this session, please feel free to challenge me. I'm pretty sure that there are questions which you know better than me, and this is also a learning process for me as well. So I would like to be challenged. And there is some material as well which can be useful for Databricks certification. So I will also stress that during during the session at some point. So the main philosophical question which I wanted to raise is what's the reason of using big data platforms processing, and why just not use a good old data warehouse, a SQL database, which is highly reliable, highly matured, and it's very it's mostly known by everyone who's dealt with data. So in many Spark literature, they mention that the Spark is just a de facto standard for big data processing. There's a lot of confusion around that, and I just wanted to emphasize that up front that Spark is not a storage. It's data processing, and the storage is decoupled from Spark. So it's not a competitor for cloud platforms such as Google Cloud, Azure, and AWS. And I'll talk about the architecture later, but just wanted to emphasize that as well. So when I say and when it says in the literature that it's a standard for big data processing, so let's just answer the question: what really big data is? There's a traditional definition, and you can find it in Wikipedia as well. That there are certain characteristics when we consider big data. So first of all is the volume, and of course it's relative. So we're talking about petabytes, terabytes of data. There's also some which component as velocity, which means that every day we have gigabytes of um, increment, and the variety of the data. So it means that the data can be of different formats, and usually it's unstructured data, such as blob storage, video files, some parameters, and the schema is not defined. There is some research which has done in Oracle that 80% of all the data which is now received is not structured. So there's no really schema. And traditional databases, SQL databases, cannot really deal with that. So there should be no SQL, but I'm a bit diverging from the topic. And there is another definition which I feel like it's a simpler one. So, and I think it's more practical. So big data is the data which cannot be stored in a single database. And I should also mention that some RDBMS systems such as Teradata and Oracle, they still support clustering, and they still support different machines. So you can still have the same interface and same SQL language. Uh, at the same time, you can also have unstructured data there, but it's a kind of a different domain, a different branch in data processing, which sometimes is isolated from all the contemporary trends. So, but I think it's fair to mention that it's developing in its own directions, this clusterization of databases. Let's just touch a bit of the topic of how big data developed and what's the usual example of how and of what happens with computations and data processing. So probably before the beginning of 21st century, the hardware characteristics grew exponentially. So it meant that every week, every month, there was a new microprocessor, or the memory just increased. And everyone thought that it would just go for ages. We could just expand the hardware ability as indefinitely. But that was not the case. So at some point, it was we just reached some limits where we couldn't really process data fast with a single machine. And this is an analogy of a person who is very strong and a heavy lifter, and we can actually develop and he can develop muscles, but there is some point where he cannot really lift things by himself. So probably 10 average people can do a better job than one single power lifter. There's also a classic example of M&M's candies, where you aggregate a simple aggregation task when you need to count M&M's of particular color, and when we can use parallelism when certain people, we just split the M&M's buckets with by smaller buckets, and this is an analogy for petitions in the data, and then each person just counts their part, and they just aggregate the results together. I like an example of a phone book more. When we have phone book, phone book dictionary, where we need to find a certain phone number. And if one person tries to do that, it's going to be a very long time. But let's just assume that we have 10 or even maybe 100 people. And so what they can do, we can they can split the tasks. We can split the pages of the phone book, and and 100 people can solve this task really fast. So these were the kind of problems and ideas which first was encountered by Google corporations, because they started to gather the big data first, one of the first companies. And they internally they developed a few technologies, but at the same time, they did scientific research. They published some papers, and they came up with this concept of GFS, Google File System. And then there was a competitor at the time, Yahoo, who was actually working, who needed similar solutions, and they came up with Hadoop project and Hadoop file system, which many ideas were borrowed from Google. And there's also MapReduce. So when I hear MapReduce, I always ask, what are we actually reducing? So we're reducing the network and communication, which means that we try to push the code to the data rather than trying to get the data and getting the code. This is why, for example, if you have a SQL database and a Python client, it's always if you can do the things with SQL, it's just better. It's just faster to do it with SQL and then get the results to Python. So in 2003, in 2006, Yahoo donated these projects to Apache Software Foundation, and there were a couple of many tools related to Hadoop, for example, Apache Hive, Apache Storm, Apache Yarn, which stands for yet another resource negotiator, sort of competitor, open source competitor to Kubernetes, but a predecessor to that. So there were some drawbacks of that software. So there was first of all, it was the performance. So the operations were mostly done with disks. There was no caching, and other drawbacks were the complexity and reliability. Because of these things often come together: complexity and reliability. If a thing is too complex, it's sometimes not very reliable. And people try to solve this, developing these tools. And then there was a project in University of California, Berkeley, and a group of people in AMP lab, or it was Red Lab, and then it was renamed a few times. I just looked it up. There was also a good investment from U.S. government, and by the way, I should say that U.S. government did really good investments at certain points. For example, internet and ARPANET. So in 2009, a group of people, and these are actually the same people who later founded the company, Databricks. They started to work on the project called Spark, which meant to solve all of these problems, complexity and unification of the API. So they came up with much better dealing with parallelism and leveraging the abilities of hardware of having gigabytes of memory. So Apache Hadoop wasn't really using hardware that efficiently. So they solved the performance problems, and they also simplified the API. They came with this concept of RDD, which I will talk about later, resilient distributed data set. And uh, all the entities, all the data sets were actually descendants of this RDD. So the project became quite popular, first in the US, and then other even private companies started to invest into that. So in 2013, it became widespread, and these people who initially worked on Apache Spark Spark first, then they donated Spark to Apache Software Foundation, so it was started to be called Apache Spark, and founded a company called Databricks, which contains many useful features on top of Apache Spark. For example, cloud optimization. So Databricks works in the cloud. At the same time, easier cluster management and other things such as notebooks and collaborative technologies. So in 2014, the first version of Spark was released, and Databricks. So they were formally independent project, but of course they were developed together in parallel. So the Spark open source software and Databricks. And it got to the point when in 2021, Databricks partnered with Google. So it worked with Azure and AWS. AWS was the first. And Databricks now works on three most popular cloud platforms. There were discussions around IPO of Databricks, but I haven't seen that. I just looked up the capitalization of the company, so it's more than 2,000 employees now. A few private investors, including the first founders. And it's just growing quite fast. So Google and Microsoft are investing to that. The revenue is mostly obtained through big clients such as Starbucks. Who else? I cannot really recall right now, but there were a couple of few big ones, big fishes, right there. So, what is actually Spark and what is Databricks? Just to summarize, so Spark is a unified engine designed for large-scale distributed data processing on premises, in data centers or in the cloud. So Spark can work in a single machine. It has a lot of modes, as opposed to Databricks, which works in the cloud and optimized for the cloud. So what Databricks adds easier cluster management. So you can just jump on without worrying about administrative stuff. So Databricks provide really sort of IPyNB Python, so it's similar to Jupyter, and there's another famous notebook engine for Python. Forgot, please remind me if you remember. And apart from that, Databricks makes a lot of money by education and providing sessions all over the world. So it also conducts annual Spark forum, and there's a lot of developers, including the founders, who speak. I was at that forum, but it was really not convenient at time in terms of the time difference, but still it was very interesting, and I listened to recording sessions. There are a couple of links in this presentation as well. So let's just go through Spark characteristics and ideas which the developers came to, even starting from the version 1. So first of all is speed, which means caching, effective caching in memory, effective use of memory, as opposed to Apache Hadoop and Apache Hive. So easy to use, really easy API. It's just similar to pandas, so many Python developers could switch to it. And the killer feature, which I will talk about later, is the SQL. So it just became very similar to a database, but it's not really a database. We will talk about it later. Modularity. So it means that you can write modules and applications in in 4 languages. So among them is Java and Scala, which is actually based on Java virtual machines, and it's native to Spark. And I didn't really find any examples where the Scala is used separately from Spark. And please correct me if I'm wrong. I think they just come together. There's also Python. You can write in Python. You can write in R as well. It's a whole different topic. So, there's a few books on in Spark. And the last feature, which they came up with is extensibility. So the storage and the processing of data are decoupled. So it means that Spark is focusing on the processing, on batch processing, but it can connect to many different sources of data. It works really well with different file systems, different file formats, starting from CSV and ending with Parquet. And there's also extension of Parquet, which is called Delta Lake, and it comes with Databricks, and I'll talk about it later as well. And it can even connect to databases, so it can through JDBC, and there are a few connectors to databases. So you can basically combine Databricks, combine Spark with databases, and use the advantages of both. So there's an article from a person, and I have a link who actually investigated that and tested how well it performs. It was not a recent article, but still very interesting. It was actually a diploma work of one of the students, which I found. I remember the surname of the student. It's Corona. Anyway, so this is the four properties of Spark. Let's just go through the architecture and talk about each concept of Spark, just to give an overview. And by the way, this is a very, very common question in Databricks developers exam, so probably covers 10% of all the questions in terms of what application, what Spark session is. So the parallelism in Spark is ensured by having a driver, which is a program who manages all the execution. So in our case, for example, in the case of a phone book, it would be some kind of leader who tells who cuts the phone books and split it into parts, and this is called the driver. And there are executors. Usually, if it's a cluster of machines, cluster of different, would it be virtual machines or just physical machines in the data center? It doesn't matter at this level of abstraction. So usually executors, they sit on one executor sit on a single machine. These are called worker nodes in Databricks. And once the application is run, so it gives the control to the driver, and that driver runs the executors, the tasks, and then the job consists of tasks. Tasks run on each executor, and then there are stages of tasks as well. So this how it's all executed can be really visually seen in Spark UI. So I really admire how they did this visualization of how the job are running. I feel like it's much better than in many databases. At the same time, it's complicated. There's a concept of RDD, and starting from a certain version of Spark, I think it was 1.3, they came with this data frame, which is similar to, I think it was even from the version 1, which a data frame, which is similar to Pandas data frame. The data frame is a interface, which doesn't mean that it contains data. It just contains the information how to get the data. Data frame is immutable, so it means that we cannot change the data frame as opposed to pandas, for example. I think you can change a data frame, and correct me if I'm wrong. But and there are only two types of operations in Spark. So one of them is transformation, which means that we create a data frame from another data frame, and it doesn't contain the data. Again, it just contains the information, and it's called DAG, distributed acyclic graph. How to calculate the information, how to calculate this particular data frame. There are actions. So you don't get data until you really have to. There are just certain actions, show, take, count, collect, and save, where you really need to get the data and to calculate. So this is called lazy transformations, and it allows to optimize data frames even before it needs to take the data. Of course, there are some drawbacks. For example, you cannot really see some errors at the compile time, or when you write a SQL, sometimes you don't see the errors until you actually execute and get the data. But the advantages really overweigh the drawbacks in my mind. I think it's a really great concept. So I also want to mention that there are two types of transformations, which change partitions and which don't change partitions. So narrow dependence. For example, if you need to filter a data frame and create another data frame, so which this operation doesn't really need to change partitioning, and there are uh, aggregation transformations where the partitioning change. So, for example, one partition in the resulting data frame can be obtained from different partitions in the underlying data frame. So let's talk about use cases of Spark. When we really need to use Spark, it's one of the main applications of Spark and Databricks as well, is that it can run and prepare data for machine learning application, which are becoming very popular nowadays, and many companies try to use AI solution. So, for example, you have a random forest algorithm. You need to have a few iterations to calibrate the parameters of this, and you can do it in parallel. So you can run machine learning algorithm in a cluster, and it will just run different algorithm, different parameters, different nodes, and that is a great use case for parallelism. Another big use case is data engineering, batch processing tasks. When you have different kind of sources, um, databases, files, um, IoT, so Internet of Things, and there's also such thing as streaming, structured streaming, implemented in Spark 3.0 for that. So milliards, basically all sources have the connectors, and this is thanks to decoupling storage from the processing. You can perform ad hoc queries on and visualize data sets as well. So this is when Spark with data storage becomes a lakehouse. We'll talk about these use cases later. Just to mention that Spark wasn't initially a database. It's a big data platform for processing big data. But once it started to get more popular, it started to get to a certain limit of usability, because data people are used to SQL. Structured query language. So they decided to introduce structured query language as it was introduced in Apache Hive. So the internally, it's still Spark, it's still big data, which is optimized for working with file storage. and raw files. But as for the user, for the average ordinary user, it looks like a database because it has a SQL feature. The session, the meeting, the learning session is called 3 Spark 3.0. I should talk about some new features compared to versions of 2.3, I think the last was. They are mostly focused on performance optimization. So 3 of them. There are new types of join hints, dynamic petition pruning. So it's when you can actually skip some petitions and it's calculated based on a cyclic graph. So there are certain conditions when they can be applied. I will not go into the details much, but I'll probably leave it for the next session. There are a couple of features, convenience features such as catalog plugin. Very useful feature of structured streaming. So you, for example, you can connect queuing mechanisms such as Kafka event hubs to Spark, and more extensive pandas support. So you can migrate your pandas notebooks from to Spark and Databricks. There's also some. So this is also a performance feature. So using this all sounds amazing, and all of this development and investment into Databricks. But what about databases? Are they becoming actually obsolete? So do the can they are they still valid? Should we really use them still? Um, Before doing that, let's just I was going to demonstrate a couple of that how you can download Spark and play with it without even without Databricks. And I should say that Databricks is great for collaborative work, so it has some extensions to Spark. But at the same time, if you, for example, certain that you need only one cluster or certain clusters which need to be working all the time, and you have developed all the code, and you're not really developing the project. It's static. So there are certain use cases when you don't need Databricks, and it's going to be much cheaper just to spin up a virtual machine and run a Spark there. So this is what I've done. I just bought a virtual machine for $3 a month with Ubuntu Linux, and installed Spark there. Not really installed, just basically extracting from the archive. I loaded the examples from a book on learning Spark. Let me just connect to that machine. I think I got disconnected. Let me connect again. So the name of the machine is really funny. For the kitchen. I think that's the name. This root. You look up the password. Cool. So we're connected, and let's just look at the examples which they give in the book. Okay, probably it's not the right catalog. I should probably switch to share, then Spark catalog, then Vim. So this is our program dealing with CSV file. So we're reading a CSV file here, reading in a data frame. So this is Spark session. So this is the single interface to all Spark abilities. So we just get a reading from a file showing first five records. Then we aggregate that and show the result. After that, then we get we get California colors and just show the result after. Okay, let's have a look how it works. So I run it at some point. So we're using Spark submit to run the script, and it has a parameter of CSV file. So we have quite extensive log files. Quite an extensive log. We saw the result somewhere. I should probably run it again without too much logging. Let me modify the log file. There was a command of opening log properties file. Here we go. So let's just eliminate info and then substitute it with warn, saving the file and just running again just to see less logging. While it's executing, okay. So this is the counting of colors. Pretty, I think it's around million of rows, more than million rows in a. Yeah, it looks like more than million rows in the CSV. So this is our California M&M, so just first 10 rows. This is just to demonstrate that you can run Spark separately, and you can also run Delta connector on that Spark, and this can really minimize the costs of processing if you just know what you're doing. At the same time, there is also a Databricks Community Edition, free with one cluster. And let me just switch to that. So just Google Databricks. I'll just probably hide the bookmarks bar. Okay. Interesting, it didn't hide it. Show bookmarks bar. Maybe I need to restart the Google browser, the Google Chrome browser. Okay, it's still showing me the bookmark manager. Anyway, I'll just run it through using my Edge browser. So Databricks Community Edition. Okay, this is not community. Is it called community edition? I think it's called, yeah, login. Let me just log in here. Okay, we got in. It was very easy to register. In fact, I was a bit struggling to run the cluster. It wouldn't run, probably because it's community edition. Let me just delete all the clusters first. Just create another one and we'll see if it runs or not. Okay, it's still deleting. So this is our training cluster. Let's just create everything default. I don't change anything. So we're just trying to run. Community optimized. Okay, we'll see how it goes. Um, I think the priority is not for community edition. That's why you can wait for quite a long time until you can run a cluster. But this is mostly for demo purposes. I would prefer to use Spark if I want everything free. Okay, let's go back to the presentation. And before answering the question, are the database actually obsolete, and we should use new technologies of big data for every single task which we're dealing with? Let's just touch one philosophical question around the technologies which we end up stuck with sometimes. So, in your opinion, let me ask you, maybe you don't know this story, maybe you do, and maybe it's also arguable. But these are two classical layout keyboards. The first one is QWERTY keyboards, and the other one is Dvorak keyboard. And what do you think is more efficient? I'll give you a couple of seconds to think, and I can tell that at least the rumors are that the first keyboard is not the slowest keyboard layout which we could think of, and it was actually designed to slow down typists at some point. It was in the end of, I think, end of 19th century when it was designed. And because the typists were so quick and the technology of the typewriters were not so quick, they just designed this keyboard to slow them down. And that stuck. And later on, all the this is the most popular. So my question to that: so what would I choose? I would choose the first one anyway because it's the most popular one. So this is the lock-in effect in the economy. And I think this is one of the biggest reasons why we use one technology over a different technology, because of the learning curve, because of the lock-in effect. So more people, for example, Git has become popular. So it was locked in GitHub. I don't think it's the best version control system. There are some certain features that are optimized for offline work, but I think there is some complexity around that. So Subversion seems quite easier to use. But Git is the most popular. So 90% of all respondents in Stack Overflow overview in 2021, 92% they answered that Git is the most essential tool for a developer. And that because of that lock-in effect, I would rather learn Git over Subversion, even if it's not the best system, just because many people use it. So this could be the reason of using new technology rather than old one. At the same time, uh, I I dug. Um, I had a bit of I did a bit of research on um, on uh, on the use cases of databases done which are done and the lectures which are done by the Databricks people themselves. And they actually, some of them are very honest developers. They're not focused on selling. They just they just say that there are use cases when actually RDBMS systems they perform much better with for certain tasks. So let's just think about it from the user perspective. So to have so Spark it declared as an advantage. So storage is decoupled for processing, but do we really need to decouple it from a user perspective? I don't want to install two systems. I just want to one system, RDBMS, which takes care of that. For example, Postgres, it just takes minutes to spin up, and you have SQL straight away. You have the storage. You can create tables. You don't have to and you have the security model as well. You just create users and give them the privileges, and that's it. You solve the problem, and that's why that I think the system, big data systems, will never be used for websites. It's not an alternative for RDBMS, especially for OTP systems when you need transactions which happening every milliseconds from all over the world. By the way, Stack Overflow itself, which is the most popular platform for developers, it's still using SQL Server 2008. I looked it up as well. So it's working quite well. It's working quite fast. I don't know if they changed it. I think they didn't. So I looked it up a few months ago. And it's just impressive work. So if you know what you're doing, if you're using these mature technologies, it just get so good results. Um, Databricks is a bit different, so you don't need to this hassle of conducting your storage and organizing the the access to the storage. You just spin up Databricks and it just works straight away, and it gives you the storage at the same time. So with a DBFS system, which is very similar to Hadoop, just called differently, and it's a bit. It's probably optimized for it's optimized for the cloud as well. So Databricks is a bit better than Spark in that regard. So you can start using it straight away from the usability perspective, but still I sometimes it's just a lot of overhead. So it can be you know just trying to use a use a gun or a chainsaw for cutting a cake. And there was a lecture which was done a few years ago from a Databricks person. They it's called "It's Not Your Father's Database," something like that. It's in the link, and they talk about the use cases where Databricks and Spark is not very good. So as I mentioned, OTP processing. Um, Random processing, which means when we use indices. So Spark is not really great. It still can do that. It looks like a database from that perspective, but it's not designed for that. It's not designed for indices. It's designed for batch processing. There's also a question in software engineering Stack Overflow where they discuss, and some people are quite aggressively aggressively defend Databricks and Spark, that it's not a database, but some people are more diplomatic, and I think that actually would be great if Spark could use indices. So indices have overhead, and it's not really. It's I think it's really hard to implement using petitioning. So if it's in one petition, I think it can be implemented, and we can still have the advantage. But at the same time, you have a database, and who can databases which can work quite well with Databricks. You just download data to Databricks in a desirable format. And if you have relational structured data, you cannot substitute a database. It's just the best tool for when you have the structured data, when you have the scheme of, I don't know, the third normal form. The You don't have to use Databricks or Spark. It's just easier. So the real use cases, and we just go back to probably the slide where I put it. Where was it? I'll find it. Yeah, so data science and data engineering of batch processing and some ad hoc analysis, though it doesn't really perform as well as in databases. So still probably if you really need performance, it's still easier to for random ad hoc analysis to download it in a database, but it's quite well if you optimize that, if you create some denormalization or some duplication of data, because the data is cheap. This is another advantage of big data processing platforms, as opposed to databases where the data is really expensive, can be really expensive. Let's go back to so in these use cases, we don't really build a data warehouse in a classic understanding, but we build a so-called lakehouse, and this is a sort of a buzzword which is used by mostly Databricks. If you Google lakehouse, you you will have the results of mostly Databricks articles, and this is the term which is also used by Snowflake, if I'm not mistaken. So, what is a lake house? Lake house is a data lake plus some data warehouse features. For example, um, ability to have schema, to impose schema on the data, ability to do business intelligence reporting and asset transactions. So it means that it's atomic, consistent. Let me just Google it. Maybe someone can remind me what it actually stands for. I just forgot. So it means that it's transactional. So they are. So all the operation can be either okay, atomicity, consistency, isolation. So they don't affect each other, and durability. If it removes 10 from A, it adds 10 from B. Was a success how the changes are still queued, waiting power falls and the changes are lost, but they assumes understand that the changes persist. Okay, so okay, the changes persist. That's the durability. Okay. And also, they declared Databricks declared that structured streaming is a innate feature of the Lakehouse. I don't think it's the case, but anyway, I should mention that. So what actually can help with building a day lake house in Databricks. There's a new project, Delta Lake, which is formally it's a use open source project. It's separate from Databricks, but in fact it's supported by Databricks developer. developers, as far as I know. And it's a storage layer on top of the file system, which based on two technologies. It's a Parquet, and at the same time, there are additional files which store the metadata information about the Parquet files. So basically, it's just a directory in the Delta table, a directory in the file system, and it can be accessed by Delta Engine. So Delta Engine can be separate from Spark as well. So you can basically do some SQL queries on this directory, and it's transactional. So you can do updates, merge, and upsert and to the data, and the implicitly or simplicity you always save history. There's a way of vacuum. This is a bit of surprising feature. Sometimes you don't really need it, but just because it's the default table in a data lake, you just have this history and you forget to vacuum the data, and you just end up with massive storage consumption. That was the case in one of the payment systems which I encountered with, and the solution was just to vacuum data, just not to forget about delta tables. And the most pleasant part is just looks like a normal relational data table. In fact, it's of course not, because it's in a file system, and these file system is distributed across multiple partitions. Uh, Usually Hadoop or file system, DBFS, or Data Lake, and that's one of the selling points of Databricks as well. There are links of Delta Lake below. I want to talk about competitors a bit. So the main competitors which I know for Databricks, if we just scrap all the databases, everything which uh, exists, so I still consider that before even making any decisions of using a big data platform, which may be a good strategic decision. So maybe just use technology for a small task to, and it can be political as well. There are a lot of reasons why you want to do that. But if it's just a technical perspective, just consider using a simple database. Maybe you end up with much less cost. So in terms of competitors, we have Snowflake, and as far